All right, I'm now moving on to some indefinite integrals for inverse trig functions. And for the homework questions in this video homework guide, I do have some of the antiderivative formulas for inverse trig functions here on the right-hand side, and we will be using them for the next few problems to work with some of these questions. Now, for some of these entry-level inverse trig functions, what you're really doing is you're just rewriting the original problem in a way so that you can actually use the antiderivative formulas here on the right-hand side. They're really not that hard, especially for the first three. So for the very first question, I noticed that there's a 4, which is a constant. And what we're going to do with that 4 is we're just going to pull that to the front. So if I pull that to the front, it's going to look like 4 times the antiderivative of 1 over the square root of 1 minus x squared times dx. All right, so once you've kind of removed that constant, take a look at this integral right there, and it actually does match up with one of the formulas here. So the antiderivative of 1 over the square root of 1 minus x squared dx is actually going to be the inverse of sine x plus c. So I can write this as the inverse of sine x plus c, and then the coefficient of 4 can just tag along, and I can multiply that by a 4, and this would be your final answer. And that's it. So you're just rewriting the original problem so that you can use one of the reference formulas on the side, and then you can just pretty much finish off the problem. Okay, question number 2 is pretty much the same idea. This time my constant is an 8, so I can move the 8 to the front. So that's going to be 8 times the integral of 1 over x squared plus 1 dx. And then ask yourself, does this integral look like something from one of the formulas on your reference sheet? And it does. If I take a look at this, the antiderivative of 1 over x squared plus 1 is going to be the inverse of tan x plus c. So this is going to be the inverse of tan x plus c, and then the 8 just remains at the front. So there's your final answer for that problem. Okay, question number 3, same idea. So I will try my best to do this a little bit faster. So the -5 comes out in front. Integral sign, 1 remains on the numerator, divided by x times the square root of x squared minus 1 times dx. And then once again, anytime you have some of these fractions, that's a good indicator that this is probably an inverse trig problem. And you can match that up to one of the identities on your formula sheet, which is this one right here, which is secant, the inverse of secant x plus c. So I would write that as the inverse of secant absolute value of x plus c, and then the -5 would just remain in front. Okay, so those ones aren't too bad, those first 3. And then I think the first 3 are just kind of giving you an opportunity to find different identities on your formula sheet there. Now for the next question here, this one requires a little bit more work. So on my numerator right here, I'm just going to rewrite that as x squared plus 1 and then minus 2. So x squared plus 1 minus 2, that still equals to the original problem. So we're in good shape over there. And then what I will do now is I'll just rewrite my integral like this now. So here's my integral sign. And then I'll write x squared plus 1 on that numerator, divided by x squared plus 1. And then I'm going to take this minus 2 here, and I'm going to write another fraction over there as minus 2. Divided by x squared plus 1, and then I'll have my dx at the very end there. So what I'm doing right there is I'm creating 2 different fractions with the same denominators. So if you have the same denominators, you can combine the numerator, and this is actually basically it's pretty much the original problem. I'm just kind of rewritten the problem in a different way so that I can actually solve the problem. All right, so do take a few seconds there to look at that expression and convince yourself that that line is exactly the same thing as the original problem. Okay, so after that, I will now simplify this. X squared over x squared, that's just going to be 1. And then we have a minus 2 over x squared plus 1, and then the integral sign with the dx. Now, what I'm going to do next is I'm going to take this integral sign here. So this integral sign right there, I'm just going to distribute that onto both of these terms here. And if I do that, I get the integral of 1 times dx minus the integral of 2 over x squared plus 1 times dx. And then I can take my 2 here and move that to the front. And so this is now going to be the integral of 1 times dx minus 2 times the integral of 1 over x squared plus 1 times dx. And now we can actually solve the problem now. This isn't too bad. The integral of a constant right here, that's just going to be x minus, and then this 2 right here is a constant, so I can leave that alone. And then ask yourself, this box right here, this actually matches up with the inverse of tan. So this would be now the inverse of tan. So tan inverse x plus c. All right, so that's how you would finish off that particular problem. So you do have to rewrite that problem using 2 different fractions, simplify, and then just use some of your basic antiderivative rules along with the inverse of tan as well at the very top there. Okay, so that's it for those first. That's it for those first 4 questions. For the rest of the video guide, I want to work on a few double angle identity problems. So this is going to be example number 7 in your workbook. And now, when you're doing double angle identity problems, one of the reasons why they're called double angles is because you have this exponent of 2 right there. So once you have an exponent of 2 there, you have to be able to break this down using some other identities, and then you'll be using some other formulas to solve the problem. So these aren't like trivial questions. You have to actually rewrite them in a different way. And one of the main formulas that you want to use right from the get-go is this blue formula right here. Now this isn't like giving you the answer, it's just helping you rewrite the integral in a different way so that you can find its antiderivative. Alright, so in order to get this started here, it's difficult to actually solve this problem right from the get-go. So I'm going to take this problem right here and rewrite it underneath the initial double angle identity here. So I'm trying my best to kind of just match it up, right? Alright, so all we have to do now is just follow the formula very precisely here. We have an integral sign, so that'll be the integral of 1/2 plus 1/2, and then we have this cos 2x, right? Okay, so back on my original problem here, I have a 2 here, right? But there's not a 2 in this original identity, right? So all you have to do is you take this 2 here and you're going to multiply it with this 2 right there. So 2 times 2 is going to be 4, so this will be cos of 4x times dx. Alright, so that's step number 1. You take the original problem and you rewrite it into this integral form, and once you do that, then you can find the antiderivative. Okay, so what's the antiderivative of a constant? So the antiderivative of the constant 1/2 is going to be 1/2 x plus, now I have another constant here which is 1/2. And then I have this cos 4x. Well, how do I find the antiderivative of that? Well, you take this cos 4x and you match it up with another formula on your formula sheet there. So cos of kx, in this case, k is going to be 4, right? So then k is on the bottom and there's another k there. So you would write this as 1 over k, which is 1 over 4 times sine of 4x plus c. All right, and then we can just finish this off by rewriting the final answer out. And then if I do 2 times 4, that's going to be 1 over 8. So 1 over 8 times sine of 4x plus c. And that is your final answer for that particular problem. So with double angle identities, you basically have to use 2 different kind of, actually you have to use one property and then one formula to kind of get the final answer there. Okay, so question number 2, let's do another double angle identity problem. So one of the reasons why it's called a double angle identity is because of this exponent of 2 there. So as soon as you see that 2, and if you've done enough of these problems, you have to recognize that you need to write that integral in a slightly different way. And we're going to be using this property first. So we're going to rewrite the original problem. And in order to do that, let me just stack the original problem underneath the identity here. So this is cos squared 4 theta times d theta. So theta and x are pretty much the same types of variables, just different variables. Yep. So then integral sign, and then just copy out the identity. So there's a 1/2, so 1/2 plus another 1/2. Okay, so now there's a cos 2x, but the problem is, in our initial problem, there's a 4, right? And in the identity, there's actually like a 1 in there, right? So what we're going to do is we're going to take this 4 and we're going to multiply it with that 2. So 4 times 2 is going to be 8. So this will be cos of 8x times dx. Okay, so now that we've written the double angle identity in a different way, now we can find its antiderivative. Okay, so what's the antiderivative of a constant, which is 1/2? So that's going to be 1/2 times x plus, here's another constant, so we'll move that in front. And then I have this cos 8x, and then I can use this identity right there. So this time my k value is 8. So then my bottom number here will be 8, and this will also be an 8. So this will be 1/8 times sine 8x plus c. And then from there, I can just multiply the 2 and the 8. So that's going to be 1/2 x plus 1/16 sine 8x plus c. That is my final answer for that problem there. Okay, let's just do one more double angle identity problem, and that'll be it for this video homework guide. Okay, so for this question, once again, it is a double angle identity because of the exponent 2. This time I have sine, so we're going to be using this property here to rewrite the original problem. Okay, so let me just stack up the original problem underneath. So sine squared now would be 3x times dx equals 2. Now we have to copy out the property exactly the same, so the integral, and then 1/2 minus 1/2. And just like the previous problems, since there's a 3 here, let me put this in orange here, there's a 3 there, but in the original identity there's actually an invisible 1 there, so in order to kind of make up for that, we take this 3 and we multiply it with that 2 here. So 3 times 2 is going to be 6, so this will be cos of 6x times dx. Alright, and then just like the previous problems, what is the antiderivative of a constant? Well, it's going to be the constant times x minus, and then you have this constant, which will be 1/2. And then take a look at this cos 6x. We'll match that up with this formula right here. So in this case, k is 6, so it's going to be 1/6 times sine of 6. So let's write that out. So this will be times 1/6 times sine of 6x plus c. Okay, and then we can just multiply this out. So 1/2 x minus, well, 2 times 6 is 12, so 1/12 sine of 6x plus c. And that is my final answer for that problem.